Subtracting my y values, then subtracting my x values. My slope is 30. Okay. Remember that, as we talked about in our last unit, that your slope, your rate of change, is a relationship between your two variables. As x changes, what happens to y? And remember that it's your change in your y values, in other words, temperature, right, over your change in your x values, or in other words, time. So if the answer is 30 over 1, this is a relationship of 30 degrees Celsius for every 1 minute. So you can say like Celsius per minute if you wanted to. That's where we get our rates here, like how you've seen like kilometers per hour. It's because the change in kilometers over the change in hour is that many kilometers per 1 hour, right? Kilometers per hour is a slope. It's a rate of change. So that is our rate of change. That's in context of the situation. And there we go. Suggest a formula to model the variable t in terms of t. In terms of means that the relationship that we're creating, in other words, the equation, the relationship that we are creating has an input of lowercase t. So we're putting something into this equation that has a lowercase t. Our input is t. So if I wanted to create an equation where t is my x and uppercase T is my y, I need to go ahead and create an equation of a line. I've got a slope. I've got a series of points. I've even got the most important point, the y-intercept. So our y-intercept is 20, so I could put it into y equals mx plus b, because I have my m. And my b is what? My b, as my y-intercept, is where we crossed. It's 20. So my b is 20. So I can go ahead and put together y equals 30x plus 20. However, we want it to be in terms of the variables that we're talking about. This is an important part of modeling, that you can't write it with y and x. You have to write it with the variables that you're using. These guys that we wrote at the beginning of the problem. This would be a good time for you to, one step at a time, piano, right? One step at a time, we need to go back and follow these processes. Okay, I need to write an equation of a line. Well, here's how I write an equation of a line. I just so happen to have all the right information to be using this one as opposed to my point slope, which is typically what we use. But since I had this specific value, it was easier to do this guy. And then once I put it together, that now my last step is to use these variables instead of these variables. So I'm going to do uppercase T equals 30 lowercase t plus 20. You can even do uppercase T of t. That's like your f of x, but instead of it being f and x, it's going to be uppercase T of t equals this. And that is your final model. In other words, conclusion. A water tank drains at a constant rate. It contains 930 liters of water 3.5 minutes after it started to drain. So we're talking about a water tank. It's containing a certain amount of water. We've opened up a hole. It's draining out. And as the water level's going down, we're representing this as a function. And so we're going to think about this context of the situation that, oh, the amount of liters is going to be decreasing. So probably the line of time compared to liters is going to look, I think I'm flipped. So I think it's going to look this way, but it's going to be a negative slope is what I'm trying to go at. It says it contains 930 liters of water 3.5 minutes after it is started to drain. It takes 50 minutes for the tank to empty. Let W be the amount of water in the tank, T minutes after it starts to drain. Label your variables. W equals amount of water in tank, because that's important. Because it could be the amount of water that's outside of the tank, and that can be increasing as the amount of water in the tank decreases. But we're talking about the water in the tank. And T is time in minutes. Water in the tank is in liters. We want to find a model, which in other words, we want to find an equation. And then we want to write down the rate at which the tank is emptying. We know that the rate is really our slope. But I'm going to save that for later. Right now what I want to focus on is how do I write an equation for this? So we're not given a line like we were before, but we know that it's really nice to have points. The points can come from a graph, as we had with our previous example, or they can come from a word problem. So if you're asked to write an equation, you probably have all of the information you already need in this problem. And we want to find points. Remember, in word problems, that points come from a pairing of numbers together. When we see number compared to this, number compared to number, those guys are a pair of numbers. They go together. It's why it's called an ordered pair. They go together. So if we just represented our variables like this, you could also take a second and realize that time is going to be like our x, and w is going to be like our y. And so you could write tw as a point. So if you're creating points, this might be a helpful frame of reference of knowing which number goes where in this point. So if I have something like a pairing of 930 liters of water to 3.5 minutes, after 3.5 we have 930 liters left, that's a pairing of numbers. That is a point. The point is 3.5 930. That is our first point. Can you see how maybe somebody might accidentally do 930, 3.5? This is why it's really important to establish what your variables are. And if you might see yourself making that mistake in the future, potentially, this would be a really good thing to do. Writing down, oh, okay, so T is like my X, W is like my Y, so this is what a pair would look like, an ordered pair of a point. There is more pairs to be had. It says it takes 50 minutes for the tank to empty. I want you to go ahead and try to make that point on your own. 50 minutes is time, right? So I would put it in my spot for time in my point. And then I think, well, wait, what would be the W? How much water is left in the tank? Well, if it's empty, the amount that's left in the tank is 0. Now above we had our y-intercept, and that was really helpful, and we could use our y equals mx plus b in order to put together the line. This is an x-intercept, which cannot be used for our slope-intercept form, which means that we need to use our point-slope form in order to make the equation.